Crash Course Instrumentation, Video 2, Thermodynamics and Unit Conversions. Welcome back to Crash Course Instrumentation. Today, we're diving into two incredibly important and often misunderstood topics, thermodynamics and unit conversions. These are foundational concepts not just in physics, but in instrumentation and engineering as a whole. Let's start with thermodynamics. At its core, thermodynamics is the study of heat and temperature and how they relate to energy and work. In the world of instrumentation, understanding thermodynamics helps us control and measure processes involving heat, like steam systems, refrigeration, or chemical reactions. First, let's clear up a common confusion: heat versus temperature. But temperature is a measure of the average kinetic energy of the particles in a substance, basically how fast the molecules are jiggling around. Heat, on the other hand, is energy in transit. It flows from a hotter object to a cooler one, always seeking equilibrium. Instruments like thermocouples, RTDs, and infrared thermometers rely on understanding this distinction. These tools don't measure heat directly, they measure temperature, which we then interpret based on system knowledge. Now let's touch on the heat transfer. There are three basic modes. 1. Conduction. Heat transfer through solids. Think of a metal rod getting hot at one end. 2. Convection. Heat transfer through fluids. Picture boiling water circulating heat. 3. Radiation. Transfer of heat via electromagnetic waves. The sun warming your skin is a perfect example. All of these can occur in process systems, and sensors are designed to handle the challenges of each. For example, a temperature sensor in a furnace needs to withstand radiant heat, while one in a pipe needs to account for conduction or convection. We also encounter terms like specific heat and enthalpy. Specific heat is the amount of heat required to raise the temperature of a unit mass by 1 degree. Enthalpy is the total heat content of a system. It's useful for evaluating energy transfer during processes like phase changes, e.g., water to steam. Speaking of phase changes, these occur when a substance moves between solid, liquid, and gas states. Energy is absorbed or released during these changes without altering temperature. Steam systems rely heavily on this principle, and instrumentation plays a key role in monitoring pressure and temperature to manage these transitions efficiently. Now, let's shift gears and talk about unit conversions. Something that seems simple but trips up even seasoned professionals. In the instrumentation world, you're constantly switching between units. Pressure might be measured in psi, bar, or pascals. Temperature could be in Fahrenheit, Celsius, or Kelvin. Flow rates, distances, volumes, you name it, there are multiple units for it. The trick is to use unity fractions, which are conversion factors equal to 1. For example, to convert 10 inches to centimeters, you multiply by the unity fraction, 2.54 centimeters, 1 in. It's the same value, just expressed in different units. This approach avoids the mental gymnastics of memorizing formulas and ensures consistency in your calculations. It's also crucial to pay attention to dimensional consistency, making sure your units cancel properly across calculations. If you're solving for power and end up with units like kg/ms, something's gone wrong. Always track your units like you track your numbers. One last tip: get comfortable with standard physical constants, like the speed of light, Planck's constant, or the gas constant. These often appear in instrumentation equations and calculations. To wrap up, thermodynamics helps us understand and control heat-related processes. Unit conversions make sure we're speaking the same language when measuring and analyzing. Both are essential tools in your instrumentation toolkit. Big thanks to Tony R. Kuphaldt and the open source community for making the Modular PDFs freely available. You can find those resources at http://ibiblio.org, Kuphaldt, a Socratic model. Be sure to like, subscribe, and stick around for more deep dives as we keep breaking down instrumentation, one concept at a time.